Shalom to you. Okay, so we are going to try to record this video for you and to review for quiz and test. So chapter 9. So the summary of the arcs and relationship between arc length formula. Again, when you have a central angle is equal to the arc measure if the angle is formed at the center of the circle. And the inscribed angle is when the angle is formed on the circle. So the arc that is connected the two endpoints is going to be the arc subtend to it. So the angle is 1/2 of the arc inscribed. Now, internal angle is when the angle is formed inside. So you have like vertical angle is formed inside. So if you have this angle that is shown, it's going to be this 1/2 of the sum of the angle in front of it, the arc in front of it, and the arc behind it, because those two angles are equal by vertical angles. That's internal, when the angle is formed inside and not the center. Inside but not the center, anywhere inside. Now, external angle is when the angle is formed outside the circle. Outside the circle. So it's going to be enclosed by two arcs. One major arc, which is on the circle where the end point of the two line segments or two rays that form the angle is. And then the smaller arc that is closer to the angle. So you subtract, you find the difference of the big one minus the smaller one and take 1/2 of that difference. Okay? So quick summary. Now, the circle length, the length. Okay, this one will be the new one. So the same angle when it's from inside, when it's from outside, but how is the length related? So you see the segment, okay, that's the one you do in exploration. If the angle is formed inside, the length of one segment, these are two chords. So the length of A times the remaining part of that, which is B, multiply it. You're going to equal C times D. So the product of each part of the chord, they are equal. Okay? And here, this is when you have one tangent and one secant. A tangent and the secant. So think of it outside, the angle is outside. So you're going to add the whole length. So A plus B is the whole length of the secant plus the part that is outside the circle, which is A. And again, you take the whole length plus the part that is outside the circle and is going to multiply them, and then you're going to equal the product of the tangent, multiply the tangent by itself. Okay. And then this is when you have two secants. Two secants, you do the same thing. You take the whole secant, the length of the whole secant times the part of the secant outside the circle. You're going to be equal to the other secant times the part outside the secant. Okay. So this is what you need. If you just remember these three basic things for the line segment connecting chord, secant, and tangent, their relationship. Okay. Again, this is what you're going to find out in your exploration. Okay, let's do example here. So we are given this. We look at where does the angle form. It's inside. There are two chords. So we know the product of one part of the chord and the other is going to equal the product of the other chord part. So we set it up. So it's going to be 4 times 3. Right? It's going to equal x times 8 minus x. Right? Because 8 minus x and x are on the same chord, so you multiply them, and they're going to equal 3 and 4 are on the other chord, so they equal each other. Okay, so multiply that 4 times 3 is 12. And then here, 8 and 3 and x are not the same term, so you distribute. So x times 8 is 8x minus x squared, right? Look what we get. So we have a quadratic there. So to solve for x, we're going to solve it like quadratic. Make everything be on one side. Since x squared is negative here, we want to add it to the other side so it becomes positive. So it's going to be what? X squared, subtract 8x, and then keep 12 on that side. It's going to equal 0. Okay? Are you there? Okay. Now, so how do we factor this? All right, so we will have two numbers, 6 and negative 6 and negative 2. So if factor, again, if you can't find number, you can also use quadratic formula. Once you have the exponent squared, it can always be quadratic formula. So we have now, so x, I'll write it here, x minus 6 is equal to 0. So add 6 to both sides, x is equal to 6. And x minus 2 equals to 0. So add 2 to both sides, x is equal to 2. Okay, so those are the two possible values for x. Since both of them are positive, we are going to take them. If any of them is negative, you reject it because length cannot be negative. Okay, so watch for that. All right, so that's how to apply that theorem. So how about this? These are two secants. So secant crosses, each one of them crosses the line in two different places. But from here to the end though, so you're going to have one length of it, which is 8. So the side 8 times x. 8 times x is going to equal 12 times 4. So you take the whole length of the secant times the part that is outside the circle, the whole length, which is 8 times the part that is outside, and multiply. So you're going to get x, 8x, and 12 times 4. 12 times 4. 48. And then we divide both sides by 8. We get 6. Okay? So the common mistake people would make here, they think, oh, x is equal to 4 because it looks like tangent here. So watch for stuff like that. It's not a tangent because it touches the circle in two parts. See that? Okay. How about this one? I'll let you. So you see x has is related to an arc we know and an angle we know. So make sure you set that up correctly. So I always say angle 50 because its external angle is going to be 1/2 of what? The difference between the big arc, which is 180 minus x. Okay, so it's 180 minus x. If you do x minus 180, is going to be wrong. Big one, the outside arc minus the inside arc. So now angle 50 is going to be, we can multiply both sides by 2, right, to get rid of this 1/2, right? Yeah. So if we multiply both sides by 2, that will get rid of 1/2, and then we have 100 equals what? 180 minus x. So instead of distributing the 1/2 to both sides and getting a fraction x, it's easier to just multiply by 2 and get rid of that. And now, see, since x is negative here, if you like, you can subtract 180 and then divide by -1, but you can as well subtract x from both sides. I mean, add x to both sides, and then that will give us a positive x. Okay, if we add x to both sides, that will make x positive. And then now we can subtract 100 from both sides, and that will give us 80. So that x is equal to 80. If x is 80 there, what would y be? Well, we know that starting from here, from that point up to here is 180, and 180 plus 180, 180 plus 80 is 160, is 260, right? So from here up to here is 260, and the whole circle is 360, right? So what is left off to find y? So y, yes?
Don't you have to divide 80 by 2?
All right, so we're going to do 360 minus 260. And again, this 260 came from arc 180 plus arc 80. Okay, and then what do you get? You get 100. Okay. So next, now we know that y is 100 arc. We can find z because z starts from here, go all the way from there. So which is this 260 we already found. And it's also outside angle. So it's going to be what? Angle z is going to be 1/2 of what? 260 minus 100, right? Because y is the internal angle that is associated with that. So z is going to be, now we can just subtract 260 minus 100, and that gives 100, and then we find the 1/2 of it. It just happened to be 80 also. And so that's that. We have found xyz. All right, so here we are given measure of arc BC. So it's good to label that BC here is 40. If this is the if, so we kind of write it and then delete it again. And then EF here is 70. And we have to find measure of. So that one, let's call it that angle there. Let's call it angle X just for make it easy. So angle X is going to be what? It's outside, gonna be 1/2 of 70 minus 40 because it's outside. So 70 minus, again, when it's outside you subtract, when it's inside you add. Okay, so that will be equal to 1/2 of 30, and that is 15. So it's going to be 15 here. So this is if. So you can use the what you have to solve the other problem. So we're going to kind of erase this and then relabel it. So the next AC, okay, AC from here to here is 8 right here, and then CF from there to there is 12. AD is 10. AD is 10. Then ED, we're asked to find ED from here to here. That's what we are looking for. Okay, so how are those segments related? How are they related? They are secants, right? Each one of them is a secant. Make sure you add the whole length though. We need to add 12 plus 8. So we do the 12 plus 8. 12 plus 8 times 8 equals what? We can label what we are looking for. Label it again x. So it's going to be x plus 10 and then times 10. Okay. Again, we take the whole segment and then we multiply it by the part of the segment outside the circle. Equal the other segment times the part of the circle outside this segment outside the circle. And then we simplify. We can add 12 plus 8. We know what that is. That's 20. Follow the order of operation. Add before you multiply. 20 times 8 is 160. And here we cannot add these two, so we have to distribute. And we are going to get 10x plus 10 times 10 is 100. So now we have 10x plus 100. Now we just solve the equation for x. Subtract 100 from both sides. We get what? 60 equals 10x. And then divide both sides by 10. We get 6. So x is 6, and the x represents the ED we are looking for. And that's our answer there. All right, and the last one. Again, we are going to erase this and relabel. All right, so we are given that AD is 16. And ED is 10. ED is 10. So from here to here is 10. And then AB, to find AB. AB is over here. So let's label it X again. So AB is a tangent. Okay, it's a tangent. So I need space here. I'm going to erase this also. Okay. All right, so when we have a tangent, we just multiply it by itself. So it's going to be x times x, which is x squared, equals, and then we take the whole length. The whole length we add up, the whole length EA. So we add it up, 10 plus 16, which is 26. Let me just write it first like that. And then times the part that is outside, which is 16. So we have x squared equals 16 times 16. And 16 times 16 is, what's that?
26 times 16.
Oh my, I'm sorry. Okay, 26 times 16. 26 times 16 is 416, right? Is that a perfect square? Let's see. No. And so it's going to be the square root of that. And we can find the perfect square that goes into that. So it's going to simplify to square root of 16 times square root of 26, which is going to be 4 square root of 26. So that's 4 square root of 26. All right, that would be that for now.